Hello everyone. In this video, I'm going to solve the following question, which contains 3 exercises. So the question says, I have to simplify the following expressions and I must express my answer only with positive exponents. So all the exponents in the answer must be positive. That's actually the condition. So we're gonna solve number 1, number 2, and number 3. For number 1, if I have something like that, I have parentheses and exponent above them, on top of them, and I have another parentheses and another exponent on top of them. Okay, what do I do here? Well, first of all, let's distribute the exponents over all the terms. Can I do that? Yes, of course, because in the previous video, we said that whenever you have a times b to the power of n, if you remember, we said that it's equal to a to the power of n times b to the power of n. So whenever I have a product, I can safely distribute the exponent. And of course, we do have product here, as you can see. So it's negative 2 times a cubed times b to the power of 5. Everything is a product, so we can simply distribute the exponents. So it becomes what? It becomes negative 2 to the power of 4 times a cubed to the power of 4 times b to the power of 5, all of it to the power of 4. That's regarding the first parentheses, or the first factor. Similarly, I'm going to do the same thing for the other factor. So it is 3 to the power of 5, a squared to the power of 5, and b to the power of 3, all of it to the power of 5. In the next step, we will perform each term. Well, let's start with negative 2 to the power of 4. So we have minus to the power of 4, and we said in the previous video, we said that if you have minus to the power of an even number, it is plus. So minus to the power of even is plus, and 2 to the power of 4, it's 2 times 2 times 2 times 2. I multiply 2 4 times by itself, and it gives me 16. Next, I have a to the power of 3 to the power of 4. I have 2 exponents on top of each other, so I multiply them, it becomes 12. Similarly, this becomes b to the power of 20. And for the other parentheses, it is 3 to the power of 5, which means I have to multiply 3 5 times by itself. That is a 243. A squared to the power of 5. This means that I have to multiply 2 and 5, so a to the power of 10. And finally, it is b to the power of 15. Now, after we have performed each parentheses individually, maybe I can simply remove the parentheses. So why? Because we have a multiplication in the middle. So I can say it is 16, a 12, b 20, times 243, a to the power of 10, and b to the power of 15. Now, let's see what we can do here. Well, first of all, I can multiply the 16 by the 243, which gives us 3,888. Then I have a to the power of 12 and a to the power of 10. Both of them have the same base. And if I multiply 2 numbers with the same base, or 2 powers with the same base, I just add the exponents. So 12 plus 10, that is a 22. And similarly, I have b to the power of 20 times b to the power of 15, which is b to the power of 35. Are all the exponents positive? Yes, they are. Everything is positive. That's it. We got the first exercise. For exercise 2, we have a fraction. We have 2 factors at the top and another 2 factors at the bottom. We can perform each factor, or we can perform each side individually. We can perform the upper part and then, or at the same time, the lower part. There is no exponent here. There are no exponents, so I can simply and immediately multiply the numbers 9 and negative 8. So that is a negative 72. I have x12 and x6. That is an x to the power of 12 plus 6, which is 18, and y to the power of 4 times y to the power of 12, that is y to the 4 plus 12, that is y to the power of 16. In the bottom, we do the same thing, like 36 times negative 2, that is a negative 72. We have x to the power of 2 and x to the power of 4, that is x to the power of 6. And y squared times y. What is y? Well, we said in the previous video, whenever you have something like with no exponent, actually I cannot say it doesn't have an exponent. It's 1, right? So y to the power of 2 times y to the power of 1 is y to the power of 3. All right, let's move forward. So negative 72 cancels out with negative 72. Can I cancel? Yeah, because we are multiplying terms. So yes, we can cancel safely. Now we have x to the power of 18 over x to the power of 6. We are dividing two powers with the same base. So this becomes x to the power of 18 minus 6. And 18 minus 6 is 12. Similarly, I have y to the power of 16 minus 3. It becomes y to the power of 13. So I always subtract the top power minus the bottom power, and I put the answer at the top. Now nothing is left at the bottom. Well, I can simply put 1. Any negative exponent? No. Okay, so I can simply say it is x to the power of 12 times y to the power of 13. I just remove the 1. And this is the second exercise. Number 3. For exercise number 3, we have a bunch of exponents. We have a bunch of terms inside the parentheses, and we have an exponent of negative 2. Well, there are several ways to do this exercise. What I prefer to do is I would prefer to finish or to simplify the terms inside before distributing the negative 2. That's what I prefer to do. I think it's easier. We can get rid of the minuses beforehand before distributing the negative 2. So let's first, in order to do that, let us first get rid of all the minus exponents inside the parentheses. 4 doesn't have any negative exponents, so I copy it as 4. We have m to the minus 1. So let's move it down, right? Becomes m to the power of 1. If you remember in the previous video, we said whenever you have a negative in the exponent, in order to get rid of the minus sign, you just change it from the top to the bottom or vice versa. We also have n to the negative 30. I move it down so it becomes n to the positive 30. What about the terms in the bottom? You have 2 to the power of negative 2, negative exponent, move it up. So it becomes 2 to the power of positive 2. N to the negative 25, I also move it up, so it becomes n to the power of 25. And of course, we cannot forget the negative 2. We're just neglecting it for the moment, but later I will distribute the negative 2 and continue the exercise. What we can do here, we can still move forward and simplify more inside the parentheses. So I have 4 times 2 to the power of 2 is 2 times 2, which is 4. And n to the 25 with n to the 30, I subtract 25 minus 30. So 25 minus 30 is a negative 5. And n to the power of 1 is simply m. All of it to the power of negative 2. And right away, we can replace 4 times 4 by what? By 16. It's turn now. We can distribute the exponent, the outer exponent. I'm talking about the negative 2 here. So this becomes 16 to the power of negative 2 times n to the power of minus 5, all of it to the negative 2, divided by m to the power of negative 2, which becomes 16 to the negative 2, n to the minus 5 times minus 2, that's n to the positive 10. Negative 5 times negative 2 is positive 10, divided by m to the negative 2. Is that it? Well, no, because the question is telling us to express our final answer with only positive exponents. So I have to remove all the minuses from the exponents. So again, 16 to the power of negative 2, I move it down, becomes 16 to the power of 2. n to the 10, I keep it at the top. What about m to the minus 2? Let's move it up. So it becomes m to the power of 2. let's move this to the middle. And it is finally, I can keep it like that, or I can simply say it's n to the 10, m to the 2, and 16 to the power of 2 is 256. That's the final answer. Thus, we have solved the 3 questions. I hope this is helpful, and see you soon. Bye, everyone.